in the second video of our series demonstrating some example applications of the hardware that we described in our first video. So all of our examples that are going to be in this video and the following were used for lab materials and of course microprocessor applications too, although these are just example applications. And like we mentioned before, there's a multitude of things that you can do with this hardware board and the MSP432 Launchpad. So the first three example applications that we're going to be showing in this video all use the MSP432 Launchpad, and they also utilize the sensor booster pack provided by TI as well. So in this first lab, we are basically just trying to start to configure the sensor booster pack and be able to actually relay information read from the sensor booster pack. So in this first lab, we are trying to read data from the light sensor, which is the green LED right here. So I can see in the video, looks kind of, the rays are coming off pretty bright on the camera. And for the blue LED, I believe it's the gyroscope, which we're going to show in a second. And then the red LED is going to be the accelerometer. All of these are located, if Wes moves his finger, all of these are located on the sensor booster pack. So first thing I'll demonstrate first is let's do the light. So the light sensor, if I hold up my phone to this sensor booster pack, Wes can show where the actual light sensor is on the sensor booster pack. So if we...
So as he adds light with a flashlight, you can see the green LEDs go all the way up, but if I cover it, they go all the way back down.
And like we said, this is just one of the, for our class, it was one of the introductory labs demonstrating how to actually start to utilize the booster packs. And the two others, like we mentioned, the gyroscope and accelerometer, the next one will show the accelerometer, I guess.
Yeah, so the accelerometer, you can see as I tilt the board to the left, so the blue LEDs go all the way to the left, and as we tilt to the right.
So I was wrong when I mentioned before that the blue LEDs are actually mapping what the accelerometer is reading, not the red LEDs.
So speaking of the red LEDs are actually illustrating the gyroscope data. So as we torque the board across this axis, you can see the red LEDs jumping from left to right. And again, you know, everything kind of works in tandem.
So the reason that they all work in tandem well, like we mentioned before, actually I don't remember if we've mentioned, is that all of these boards are running on a user-built real-time operating system, which is also a big portion of the course that was offering this board and this material. Although that most of these applications can be run without a real-time operating system, they work well in tandem, like Wes was saying. So all of these sensor packs are running in threads right now. So again, if we turn on my light and then also torque the board, we see the red LEDs still coming on, and the blue LEDs. And the green is overpowering right now, but I can't tell if you can see on the camera. But if you tilt the board, let's say to the right, they're actually becoming cyan rather than just green. It's kind of hard to tell. It looks like a little weird green on the camera, I believe. But yeah, so that was the first lab. Now the second lab example application that we'll show still involves the sensor packs. Now it involves the temperature sensor pack, as well the temperature sensor on the sensor pack, as well as we wanted to start utilizing the joystick on the daughter board itself. So the joystick's an analog joystick reading ADC values from the X and Y axis. And in this lab, we actually only use the X axis. So right now, if we look at these blue and red LEDs, this right side of the 16 LEDs, these 8 LEDs are supposed to represent the temperature range that we provided in our lab materials, which is all user predefined. So in our case right now, we see that these two lights represent, I believe, a temperature range of probably around 65 degrees, let's say, right now in this room. And if we have a bag of ice here that if we put up to one of the sensors, we put up to the temperature sensor on the pack, we'll start to see that my processor starts recognizing that the temperature is dropping, and it'll start to account for that in its program, and then reasonably bring down or bring the red LEDs down and start adding more blue LEDs representing the temperature drop. And for the vice versa, so here we see all blue LEDs. So I think it dropped in our range. It was the lowest was something like 60 degrees. which of course is all user predefined. So, and you can believe us that if we keep, and I'll let Wes hold his finger on there while we're just demonstrating other stuff, you'll see that the red LEDs, when his body heat's starting to heat up the sensor itself, it'll start to actually bring the LEDs back on and make sure that it's the right sensor. But at the same time, now let's talk about the joystick. So the joystick on the left half of the 8 LEDs, when we move the joystick to the left, we program it so that based on the ADC values being read, we wanted to make sure to read the actual ADC values and demonstrate what ADC value we're receiving based on the green LEDs. And we did a, well, Wes, was it like average decay or something like that, just to be able to...
Yeah, I think it was a running average calculation to determine the value of the joystick.
So that if I let go, so I'll let Wes push all the way, if I let go of the joystick...
It doesn't instantly go back to 0, it kind of fades back.
Which allows it for more, user flexibility rather than the processor instantly detecting it goes back to 0. Which just makes it look a little bit nicer. But so yeah, so that was the big purpose of this lab, was also getting more used to the sensor packs and using, so the sensor pack were communicating with SPI. So that was we had to learn how to use the SPI module with the ARM processor.
And again, we haven't mentioned this, but the way we're driving the RGB LEDs is with 3 individual I2C LED drivers. So we had to use SPI as well as I2C to get this to work.
And right now in all these labs we're showing, we are seeing the LCD, the resistive touchscreen LCD that we mentioned in our first video, being turned on. It wasn't actually serving a purpose right now. We could have easily unplugged those for the different demonstrations today. We just hadn't unplugged them, forgotten to. But the fourth lab that we did, which is another example application, actually starts to use the resistive touchscreen. So Wes is holding the phone. So if we the purpose of this lab was to start off with a black LCD screen, and it was just to start to use also the sensor pack on here with the accelerometer, so that I wanted to, if I was able to touch the screen, a little ball appears. And now with the accelerometer reading ADC values, now based on the accelerometer values, based on the X, Y, or Z axis, the ball starts to move around the screen and comes around the screen, off the screen, back off the screen. And these are all user-defined operations on how the ball actually moves. I'm very flexible with whatever applications you want to do, but this was just trying to start seeing more applications of the microprocessor, along with we were building more real-time operating system functionality. So to come up, and this also allows us, with our multi-threading that we were doing, to add up to I think about 20 balls. And the user-defined space, we all defined that. They all have random velocities moving around. Sorry for the light fluctuations. And then I was also able to, if I can do it on here, I was also able to remove balls by clicking on the same ball. And then I could still continue to add more balls as long as that threshold hadn't been met. And again, it might be a little hard to see on here, but that was the general idea. Sometimes, there you go. So perfect.
Is that it?
Yeah, so for the purpose of this video, we're done with these 3 demonstrations. In the next following video, we're going to show 2 more or 3 more complicated applications for this board and this whole system itself.